Flow meter in Pacific Grove, California. This meter is 60 CFM and a full scale for the digital span is 20,000. We're going to adjust the remote Omron H7EC so that it communicates on the pulse terminals for the flow meter. The method of doing this is to go into Totalizer Time Log, determine how often we want to collect it, but let's see where it is now. The way to do it is to reset the totalizer. This will see reset on the device here. It's reset here. When this display switches over, we see it's 0 here, 0 here. We can turn it on, push this on, substitute on, click OK. It's going to drive the meter at full scale. So we're going to look at this totalizer and see if it agrees with this one. This one's set for the decimal point of 1, for the time rate of minutes, which must be set because the units have to agree in the time scale. So if you have cubic feet per hour, you would select hour, seconds, minutes, days. This is minutes. The decimal point we're recording is the ones. Now I'm going to show you how to set it in case you like to have a different flow rate. So what I'm going to do is I'm going to turn off the substitution by clicking this. Substitution off, drives it to 0. The totalizer should stop. I'm going to reset the totalizer here, and I'm going to reach over and reset it here. So this is resetting the mechanical totalizer, which is an electromechanical device. It's just an electronic device. Now I'm going to set it to the 10ths position. Some people may find this interesting for recording higher flow, more resolution. So I'm going to press substitute on, click OK. We're driving it at 10,000, which is 30, 50% of full scale. And we'll see now that it's 33, 35, see 35. So it's counting these digits. Now I'm going to stop it, and we note that we need a counter that has a maximum pulse rate of 10 Hertz. I'm going to stop this meter, stop, substitution, reset the totalizer, and reset this one. So it says 0. And now I'm going to look at counting at 01. And I wonder how many. It needs 100 Hertz. You can go online and look up whatever counter you have, and what you have is the max counting speed, 30 Hertz or 1 kilohertz, switchable with switch. So I looked up the H7EC, and that shows us what the counting rate is, maximum counting rate is. So we're here at 100 Hertz. So if we want to gather 001 Hertz, a decimal point of 001, this is 10 kilohertz. So I'm going to do it anyway. We'll see how fast this one can go. And I'm going to reset the totalizer, which has been done. I'm going to start the substitution, turns it red, substitute on, click OK. And now it'll be substituting, and we'll be looking at the counter 11950001, 1195. So I don't think it likes that speed. So I've determined from this test that I wouldn't use this totalizer for reading it. So I'm going to stop it, and I reset the totalizer, reset this one. I think that had a buffer. Now I'm going to do 001, which is 1 kilohertz, 1000 Hertz. Red, substitute on, click, and now we'll see if these agree. This will be 1162, it'll be these digits. So if you're comfortable with that, you can use that rate. It just depends what you want. If the rate is far too high, what you can do, so I'm going to put this to 20,000, full scale. You can make the substitutes based on the curve here. So I'm using full scale. So stop, reset, reset totalizer. I'm going to reset this one because it does have a buffer inside of there. And every 10, so this will still, it'll update. And now substitute on, reset totalizer, make sure everybody goes to 0, click. Now we'll get to watch this totalizer increment when this gets to 10. There we go. So there you have all you need for setting the totalizer and the pulse counter. This pulse counter chip is connected to a digital device. I'm going to show you a schematic of that. The chip is an LCA 110 and it's used in this manner. DC only configuration. So we have a load and plus load and minus load. You can look this device up and see what you could hook up to it and still keep that device happy. The device is connected in this manner. This is the side we're switching with the digital circuitry, and this is the side that's accessible to you. 9 pulse plus, 10 pulse minus, and it's wired in this way. So treat the device as they intend it to be treated. This is the method for connecting the Omron H7EC right here. 2 wires are connected to this device. The orange wire is on the left, and that connects to the plus, which goes to pin 3, which is pulse minus. The white wire connects to the ground, pin 1. The ground is pin 1 and 24 volts is pin 2. 24 volts is jumpered to 4 of pulse plus. The pulse plus is switched internally from the 24 volts and then comes and returns on the plus side out here on the orange wire, because the orange wire is the switched leg. So you have the circuitry here, you have the wiring there, and you could use any sort of switching system you like.